all the participants are please be patient and wait for the presenter's appearance, and he will join the session soon. Okay, sir. Participants, please wait. Dr. Ashil will join the session within a minute. Please be patient and wait for him.
Assalamu alaikum. Welcome back.
Walaikum assalam. Sir, screen sharing option already.
Yeah. Are you getting my voice and the screen?
Yes, sir, completely.
Okay. Previously, we have seen IoT and how it's different from Internet of Things. 4 different layers of IoT. We have noticed a very different applications of IoT. Lately, we have seen the adoption of IoT network in transportation. In the smart cities, the smart automation have changed the way we travel from one part to another part. Application of IoT include for transportation not only provide you the navigation, which almost all of us are now aware of us, but it also avoid collision between vehicles, collision between vehicle and human beings and even animals. Now the vehicles arrive in the state-of-the-art technology is embedded with IoT technology, and these vehicles can identify the other vehicles on the roads, and they behave like a network of vehicles on the highways. So in this way, we can monitor and manage the traffic better than we have seen a traffic jam all over the different urban center of the world. IoT has been changed drastically, and through 5G technologies, it can be maximized, optimized on various parts of the country. If you look at this particular slide, it consists of a connectivity of your automobile with satellite, especially for GPS system, a connectivity of your mobile with the coming traffic signals, and some external Wi-Fi, internal Wi-Fi, Bluetooth, these bring connections. So the human body is a core network of things. So we can say that today's and the future car is a network of sensors within the car and outside the car in the form of the whole transportation system. Like just like we discussed the IoT for human body and IoT for healthcare, likewise the IoT of transportation system and the IoT of vehicles can be combined to change drastically the way we travel from one part to the another part. Not only our travel time will reduce, but it become much safer and much safer for us in the near future. Intelligent transportation, as I already discussed with you, look at the slide picture on the right top. A vehicle try to overtake one of the another vehicles, so it will not under the normal circumstances the other car do not realize that the car behind him is about to overtake. So in the network of the in the network of the vehicles under IoT, each car communicates with another car so that it can make some smart moves and or safe moves. Safely it can, or if it can pass another vehicles without any possible collision. And if you look at this particular scenario, drivers may have warnings and emergency self-stop and traffic management using the intelligent transportation system. You can also use IoT for real-time vehicle tracking and fleet management, fleet planning information, high precision arrival times, variable data for insurance and companies. The whole transportation system, including the insurance companies, which previously rely on the human-centric information, are now much more informed than previously it was. So, for insurance company, they can make better decision using intelligent transportation system with the help of IoT. Look at the IoT for smart grid. We have been seeing that smart grid can be connected with through IoT for different application as discussed over here, including the asset performance, reduce cost, infrastructure management, supply chain, reducing the supply chain risk. And it is estimated that by the end of 2017, annual smart grid spending in China could total 20 billion, with smart meters comprise 2 billion of that. So this is was the old data of 2017 in which of China, where the smart grid expenditure is about 20 billion. Imagine after 3 to 4 years, the amount of expenditure China made only for the smart grid is in billions of dollars, and out of which the smart metering system is one of the major chunks. Okay, these are some facts and figures 2017 regarding the worldwide IoT market. Worldwide IoT market is 1.7 trillion in 2020, and it is increasing at a rate of 17%. So for every 5 to 6 years, the expenditure on this smart system is doubling, and which shows the sign of the promising future of IoT. And it estimated that 27 from 2020 reached to 1.6 billion by 2020. So market is expanding for IoT. Some different landscape, current standardization of IoT. We will skipping this slide because of the time constraint, and now we are moving to the second part of today's presentation. Let me share with you. So far, we are moving toward another slide, not this one. 3, 5, 15K. This is the second part of today's presentation on 5G. So now we are proceeding toward the second part. Previously, we have discussed IoT technology. IoT, or in simple words, connectivity of machine to machine things, and definitely machine to human also. So it's not possible without the support of the infrastructure. Any technology, for example, when we're talking about the vehicles, smart vehicles, but we do not have a right infrastructure, that technology will be failed. So likewise, if we comparing the scenario of the Pakistan Railway, for example, if we have a bullet train arrive at the Karachi port, remember the bullet trains, and we do not have the right infrastructure for that bullet trains, the whole system will will become failed. This is the example of IoT versus 5G. IoT is just like a bullet train, and 5G is a smart infrastructure that support the bullet train. So in the second part, we will discuss about the 5G technology or the infrastructure that is required for future Internet of Things. And without the infrastructure, that technology or the Internet of Technology will not move toward full-blown application, which is not possible without the new and more advanced IT, IT communication infrastructure. So let's move forward further. So this slide is focusing on 5G. Previous was discussed about IoT. Introduction to 5G. This slide will provide you some history of the generation we have seen in telecommunications as far as the wireless is concerned. The first generation of mobile communication was in 1979, which is provide us the capability of voice communication only, and it has very limited capabilities, and the telephone set are very bulky, very costly, and the application are very limited, and generally cost drop very frequently. You have no freedom for move around here and there. So in the 5G 1G communication, you have very limited capabilities of wireless communication. You can talk from one point to another point. You cannot move around. You cannot roam. You can only use the voice communication. You do not have any features of digital SMS, multimedia files, and so on. Later on in 1991, the second generation is getting much more digitized. Now, limited digital service in the form of text messaging is possible with limited capability of roaming. Roaming means you can travel from one place to another place. Previously, what not easy or not even possible. Later in 2.5G and 2.7G, we will see much enhanced data services in the form of GPRS and Edge. That was actually about the SMS and limited multimedia application you can use using 2.5G and 2.75G. After 2.75G, the generation is 1993, 98. That is called 3G. Before 4G, most of us has using 3G mobile phones, which are good for calls and mobile wireless calls, but they are not providing a great internet services. And mobile internet service was initially introduced in third generation. And after third generation, 3.5G will provide a better internet capabilities with the introduction of mobile apps. So before 3G, there is no concept of mobile app. The concept of mobile app was introduced in 3.5G, and almost all of us are now using mobile apps for various communication needs, including what we are using right now is Zoom. And most of you are not familiar with the word Zoom a year ago, and it is because of the positive impact of pandemic COVID-19 that all of us are now connected in through different application software or mobile apps, which generally we are doing this kind of seminars in the regular setup. So now you can sit at home and enjoy a quality seminars in the form of webinars by downloading different mobile apps, Zooms, Google Meet, and so on. So that mobile app was not initially present till the third generation. It has been introduced in the 3.5 generation of the wireless networks. And now we are talking about another important, very successful generation of mobile communication that is currently now we are using is fourth generation was introduced in 2008, and this is IP based, and we enjoy free video calls, free voice calls, free teleconferencing, free webinars using IP based services, which is not even possible in the previous versions. Now we are using a fast broadband internet at a reasonable cost, and we can do lot of home as well as entertainment and our commercial activities using fourth generation networks. Then generation network is the successful wireless network. And as you know that today's topic is 5G. Imagine 5G going to be drastically changing the way we are communicating with each other from first generation to fourth generation. Remember, the communication is centric, is human centric. Human centric means from first generation to fourth generation, the intention of the communication is to communicate or they provide a communication between human to humans, whether it's the first generation communication model or the fourth generation networks. So all these four is for humans to human communication. Now we are moving to the fifth generation of mobile communication. You notice that the Zong and Huawei, these are the two major players who already tested fifth generation networks even in Pakistan. So this infrastructure will drastically change the way we communicate with each other. Now the mode of communication is mostly not between human to human, rather it's between human to machine and machine to machine. This is the fundamental difference between the technology of 5G versus the previous technology. If anybody asks you about what is the 5G different from the 4G and the previous generation, the answer is that we're going to have a much more communications between machine to machine. I already shared in the previous section of the slide that by 2030, we will have 1,000 times more sensor than the population of the planet Earth. So we're going to have trillions of dollars of trillions of sensors used in various different areas, including healthcare, transportation, smart agriculture, smart grid, and so on. So in 5G communication, most of the communication will benefit it toward the Internet of Things. So now we are connecting the dot between 5G and the Internet of Things. So we can say that the 5G is just like a infrastructure for a bullet train, and bullet train Internet of Things is just like a bullet train. So without the strong infrastructure, a bullet train cannot be survived, or it cannot be applicable. So previously we have seen the Internet of Things and its application in different walks of life. Now we are looking at the infrastructure that supports Internet of Things. Beside Internet of Things, it provides different other applications, including broadband communication for general consumer like you and me. 4G is another version of the 4G where the data rate is double its long-term evolution, which is introduced in 2009. As we discussed little while ago, that 5G expand broadband services beyond internet of mobile internet to IoT and critical communication segment. So you will realize the importance of 5G when you have listened my previous presentation part today about IoT and combine it with 5G. So now we're going to see a very fast mobile internet to support IoT, a very simplistic way of explaining the difference between 3G, 4G, and 5G. Look at the picture. 3G, 4G, and the previous all different technologies are for human-to-human communication. And even in 4G 4 generation, we have limited IoT applications across the world. But when we move or enter in 5G era, we will see the connectivity between not only between human to human, but a great communication going to establish between machine to machine. We can we can monitor the power generation at the windmills. For example, if we have somebody has seen the Jhampi power project, wind power mill. So they have a very big turbines. So these wind turbines are located in a very far flung areas. So if you hire somebody to monitor the services of these wind farms, it will cost you more money. So if you have a IoT enabled 5G technology, you can easily monitor and control the parameter of remote wind farms. You can also monitor the home automation if you are far from your home. You can monitor the performance of your fleet. Suppose if you have a fleet of 100 vehicles, you can monitor each individual vehicles under an application that is supported by IoT and 5G. These are some defined details of 5G. We will start at the top right part. 5G is promising you to provide the services for 99.99% of the time. Remember, during the rainy season, we will see a blackout of the internet as well as voice calls. So the future network is going to be more robust, and they are capable of providing you the services even in heavy rains, thunders, and so on. We will see in detail how it's possible to provide 99.99% availability of services during these severe weather conditions. Likewise, they also 5G is also promise to give you a coverage of 100%. Remember, if you live in the remote areas, even in Karachi, if you live in some areas like Guldare, Ijri, or Quetta town or Gawaliar, you are not getting the broadband signal, which is a big concern for the people living in that areas. So they cannot do regular office work and different communications. So it promises you to provide you 100% coverage. You will see how it's possible. Yet another important piece of any network is the energy utilization and management. 90% of the reduction in network energy usage. The technology is so such based on such advanced components and features which save 90% of the energy. We will see in the coming slide or in some another webinar session that how it's possible to reduce the 90% of the network energy needs. Likewise, they also have a battery which can support battery life of up to 10 years for low power IoT devices. Remember, we have discussed about different IoT sensors, which is on the floor of the ocean, on the floor of the land for smart agriculture. These small sensors are capable of energy needs, which can be provided by the batteries, and the batteries are so advanced that it can handle the application for over 10 years. So this is the 5G technology that support IoT, in which the sensor do not require the change of the battery each and every time. Even it is possible to support the harvesting of the energy for these sensors. Later, we are moving toward the left part of this screen. On the left side of the bottom, it shows that up to 100 times number of connected device per unit areas compared with 4G. For example, if you live in an area of 1 kilometer by 1 kilometer and you support, let's say, user of 500 users. But in case of 5G, it can support around 50,000 or 1 lakh different IoT sensors within that area. It also capable of providing you very high bandwidth per unit area. And on the left side, top left side is about the latency, the delay between the services getting reduced to 1 millisecond. This is important for critical internet application we will see in the next in the coming slide. The data rate is going to be increased by 10 to 100 times compared to the 4G and 4.5G. Okay, this thing we already discussed. As we seen that up to 10 GBs of data rate is possible in case of 5G. And these information already we discussed. And for the sake of importance, it has been repeated over here. The latency for 5G is reduced to 1 millisecond. Likewise, number of devices it can support up to 100. It is 99% available under in the severe weather conditions, and you can reduce the energy consumption of the network by 90%. And in case of IoT sensor, it is possible that one can have the life of the battery up to 10 years. These are another important slide for 5G. This slide is divided into two important areas of the driving forces for 5G. Network. When we look at the network itself, it improves the overall user experience. Now we can support massive traffic volumes, massive number of devices, massive number of services. Remember, with the 4G mobile network and 4G mobile phone, you can connect to your family and friends. You can connect with your office work. from different portals like Zoom. You can use to buy online. You can use online transportation system. With 5G, it's been increased drastically. If we look at the technical aspect of the driver, these are more energy resource efficient. Virtualization is possible, and more technologies implement using cloud-based technology and software implementation of these smart equipment. 5 use cases of 5G. Remember, these are all communication networks which previously designed for us to talk to each other. Later is transformed to provide broadband internet through which we use number of our applications. Now 5G is moving beyond the need of humans in the form of communication and broadband. The second bullet on the right top shows smart vehicle transportation infrastructure. Previously, transportation infrastructure has nothing to do with the communication network. Remember, in 3G, 2G, we do not have any involvement of communication network for the advancement of the transportation. But with 5G, it's possible to have smart grids. Smart transportation infrastructure is capable of number of things like traffic management, energy saving, and safety of the passengers. Later, we have 5G communication for media everywhere. With 5G, your mobile, your smart television, these are all synced together, not only for entertainment, connectivity, but also for office work and number of other applications. Fourth use case of 5G is critical control of remote devices. We will see these critical control system in the coming slide. Interaction in, and finally is the human to IoT interaction is yet another important aspect of 5G. This is the one of the important slides of today's lecture. If you have, you can save this as a screenshot, and it covers a lot of different things about 5G and IoT. Diverse requirement of IoT is divided into two components, massive IoT and critical IoT. What is the difference between massive and critical IoT? As the name says, massive is a general IoT system in bulk, like transportation system, logistics, fleet management, smart metering, smart agriculture metering, in which delay of few milliseconds will not affect the performance. But when we talk about the critical operations, like you see in the traffic safety and control, the delay sensitivity of 5G will help you avoid collision between the car, healthcare system, smart automation, industrial application control, including manufacturing, training, and surgery. Look at the bottom part of the slide. The critical IoT required a network which is ultra reliable. Ultra reliable network is required for a critical IoT application. For example, traffic safety, surgery, smart automation, etc. And also required a very high availability. On the other hand, massive IoT just required low cost application with low energy utilization, small data volume, and massive numbers. As we seen in case of logistics, tracking, smart agriculture, and smart buildings. So these critical IoT operations and massive IoT operations are nearly not possible with 4G because they do not have the capability of these requirements like low cost, low energy, small data volumes, massive numbers. When we talk about massive numbers, 4G has a limited capabilities, and
Sir, sir,
we talk about critical operations due to delays. Hello,
yes, sir. We have, sir, 2 minutes
hello.
to
Due to
end this
delays
conversation.
and non-availability. Excuse me.
Sir, we have 2 minutes to end this session, and fourth
2 minutes.
part, yes, sir.
Okay. So let me spend 2 minutes to exit the slides. Remember when we have 4G communications, we do have IoT application using 4G, but it has limited capabilities, especially for critical operations. It has a very limited and unreliable mode of communication. You cannot do a surgery in a system, a remote surgery in a system in which a network is reliable and it has high latency and low availability. So in the future, it's possible that more and more physician and surgeon do healthcare services using remote control system. Even now, it's possible to have perform surgery through the, telemedicine and remote internet applications, which is difficult in 4G. In 5G, it become norm to have critical operations because of the fact that it has a very robust network in terms of latency, availability, and reliability. On the other hand, when we have talking about what 1 trillion of the sensor by 2030 or in the middle of the from 2020 to 2030, a massive number of the IoT sensor in trillions of numbers. So this is a very huge numbers, 10,000 times more than the people on the planet Earth. In trillions of sensor or a billion numbers of sensor, the service provided by 4G is it not easy, and I can say for sure that